The following question is related to electrochemistry, and the question reads that the diagram shows a laboratory illustration of a simple hydrogen oxygen fuel cell. So there's a hydrogen oxygen fuel cell drawn. There are two electrodes, one over here and one over here, and they're connected together by a voltmeter and a salt bridge. And the first part of the question reads, write the half equation for the reaction occurring at the left hand electrode, which is the oxygen electrode over here. This is the left hand electrode when the cell operates. So we need to figure out what is the reaction or the equation that's or the chemical equilibrium that is established at the left hand electrode. So for that I would need to refer to the data booklet, but before I do that I need to figure out which substances are involved in the left hand electrode. So there is oxygen gas, which is O2, so my reaction must contain oxygen. Then there is acid. The solution is acidic, so it contains H3O plus ions, or we can also call them simple hydrogen ions, having a concentration of 1 mole per dm cube. Plus there's obviously water involved as well, because it's an aqueous solution. So these are my chemicals that are involved in the left hand electrode. So I'm going to look at the data booklet and I'm going to figure out a reaction in which all these chemicals are involved in an electrode, in an equilibrium reaction. So I've opened the data booklet, and there's only one reaction that fits the description, and that reaction is this one that's given over here, where you have oxygen gas, you have hydrogen ions, and you have water molecules. So these are my chemicals that were involved in the left hand electrode. So the equilibrium that would be established would be this one, and it has an E0 value, an electrode potential of 1.23 volts. So I'm going to copy this reaction. Now I've written the reaction, but I don't know in which direction this reaction would go when the cell operates, because it's specifically asking what reaction would occur when the cell operates. Now for that, to understand whether this electrode over here is going to gain electrons or whether it's going to lose electrons, I also need to figure out what's happening at the right hand electrode. Now the right hand electrodes, the chemicals involved, there's hydrogen gas, plus there are H plus 1 ions in solution, 1 mole per dm cube. So there's only one equilibrium that could be established over here, and that is between hydrogen ions and hydrogen gas. So the equilibrium that would be established over here would be this one, 2H plus 2 electrons, and there's going to be an equilibrium reaction with hydrogen gas. And this is your standard hydrogen electrode. It has an E0 value of exactly 0.0 volts. This is used as your reference to figure out the electrode potential of all the other electrodes. Now the rule is that higher potential always gains electrons, and lower potential, the negative potential, always loses electrons. So the electrons are going to be traveling in this direction, from the negative side to the positive side. They would be attracted to the positive electrode. So the negative electrode would be losing electrons, and they would be traveling to the positive side. So this side, higher potential, would be gaining electrons. So this reaction over here would be going in the forward direction. It would be reduced. A reduction would be occurring on the left hand electrode. And this side over here would be losing electrons. So it's going to be producing electrons. So this would be going in the backward direction. It would be getting oxidized. So he was asking us to write the half equation for the reaction occurring at the left hand electrode when the cell operates. So we're going to write this reaction, but in the forward direction. So the equation is going to be, it's going to be O2 plus 4H plus 4 electrons. Remove the reversible sign. It's going to go in the forward direction, and it's going to produce 2 water molecules. And this is what was needed. It was a 1 mark question. In the next part of the question, part B, we need to figure out, we need to state the polarity plus or minus of the left hand electrode, the oxygen electrode. So going back to my diagram, we've already figured this out. I've written down the electrode potentials. This is the higher potential, whereas this is the lower potential. So according to this, the higher potential is always going to be the positive potential. So this side would be the positive side. It would be the positive electrode, and the lower potential would be the negative electrode. So this side over here would be the negative electrode. So going back to answer the question, the oxygen electrode is going to be the positive plus electrode. And next we also need to figure out, use the data booklet to calculate the voltage produced by this cell. So I've already written down the E0 electrode potentials of both sides. One side is 1.23 volts, the higher potential. The lower potential is 0.00 volts. So the potential difference would be it would be higher potential minus lower potential, or it's going to be 1.23 volts minus 0.00 volts. So this is the voltage that would appear on the electrochemical cell, and this basically comes out to be equal to 1.23 volts. So to answer this question, it's 1.23 volts minus 0.00, which is basically 1.23 volts. So this is the E0 cell of the electrochemical cell. In the next part D of the question reads, only a very small current can be drawn from this laboratory cell. Suggest one way in which it could be modified to enable a larger current to be drawn from it. So to somehow increase the potential difference, or the E0 cell, we want to increase E0 cell, we want to make the reaction even more feasible. So if I go back and I have a look at the diagram of the electrochemical cell that we've drawn over here, I need to increase this E0 value 1.23 volts. If I increase the E0 value, potential difference would increase, and that would lead to a greater voltage on the electrochemical cell. That would lead to more current flowing. Or vice versa, I need to decrease this voltage over here. It's 0 volts. I need to make it even lower. So I need to reduce this. Now there are many ways of doing that. Now to increase the voltage, I want this electrode to consume more electrons, or I want the equilibrium to shift more towards the right. So to make the equilibrium shift towards the right, this is the direction I want this equilibrium to go. What I can do is I can increase the concentration of H plus one ions. Remember Lee-Chatter's principle. We basically want the equilibrium to shift more to the right. So I can increase the concentration of H plus one ions. That would make the equilibrium move towards the right. This is what we want to do, so that a larger current could be drawn. Or what I can do is I can increase pressure of the gas. If I increase pressure of oxygen gas, this equilibrium would shift more towards the right. So those are two things that you could do. So I've written these two things: increase the hydrogen ion concentration, or increase pressure at the oxygen electrode or the left hand electrode. Vice versa, what we can also do is we can change the conditions at the right hand electrode. I want this reaction to move, this equilibrium over here to move more to the left. So I need to push it more to the left. And one way to do that is I can decrease the concentration of H plus one ions. If I decrease the concentration of H plus one ions, then this equilibrium would shift more to the left. Or what I can also do is I can increase the pressure on hydrogen gas, and that would make the equilibrium shift more to the left. So there are two things I could do on the left hand electrode as well, which is the hydrogen electrode. Now part E of the question reads that a fuel cell in an orbiting satellite is required to produce a current of 0.01 amperes. So the current is given for 400 days. So he's given you the time as well, and you have to calculate the mass of hydrogen that will be needed. Now he's basically talking about the reaction at the right hand electrode, the one that that is given over here. If you look at the diagram, the right hand electrode this is where hydrogen is getting used up. It's getting converted into H plus one. So let me copy this reaction, and if I copy this reaction, the reaction is that H2 loses its electrons, gets oxidized to H plus one, and produces 2 electrons. So this is the reaction that we're talking about. Now the first thing, you're given the current and you're given the time as well. So using the formula that charge is basically current multiplied by time in seconds. The current is 0.01 amperes. The time should be in seconds. So it's 400 days, and each day contains 24 hours, and then each hour contains 60 minutes, and each minute contains 60 seconds. So these are the seconds. So finding out how much charge is actually going through, how much current is actually being, so we're basically calculating the charge that goes through the circuit, and I'm going to calculate this current in time using my calculator. And the answer that I get is 345,600 coulombs. So that's the amount of charge that's going through the circuit. So a fuel cell, and we have to calculate the mass of hydrogen. So we basically need to to find the mass of hydrogen that is needed, you need to find out the moles of electrons that are going through the circuit. Now we know, according to Faraday's law, that 1 mole of electrons have a charge of 96,500 coulombs. So using ratios, the amount of charge that's passing through our circuit is 345,600 coulombs. So using ratios, how many moles of electrons are actually going through the circuit? So this is unknown. So using simple ratios, I'm going to use the crisscross method. So using simple ratios and using the crisscross method, X, or the amount of moles of electrons that are going through the circuit, comes out to be equal to, it's going to be 345,600 divided by 96,500 coulombs, which is also the Faraday constant. So the answer that I get is 3.58 rounded to 3 significant figures moles of electrons. So using ratios, we know that 1 mole of electron have a combined total charge of 96,500 coulombs. So if the circuit, the 34,500, that's 345,600 coulombs of charge is passing through the circuit. So how many moles of electrons? Using ratios, it comes out to be 3.58 moles of electrons. Now what I'm going to do is I've figured out the moles of electrons that are going through the circuit. So this is now known. Now using this equation over here, this particular equation over here, we know the amount of moles of electrons. That's 3.58 moles of electrons. So what would be the moles of hydrogen that would be produced? So it's 2:1. So the moles of hydrogen gas that would be needed would be 3.58 moles divided by 2, which comes out to be, it comes out to be 1.79 moles of hydrogen gas. So we figured out what is the amount of hydrogen gas that's needed, but those are just moles. So since we have figured out the moles, and we need to calculate the mass of hydrogen now. So let me just go through this once more. We found out the moles of electrons, and according to the equation, it's 2 electrons produce 1 hydrogen gas. So if you have 3.58 moles of electrons, then the amount of hydrogen gas is going to be half of that. So it's 3.58 divided by 2. And the last thing is, we found out the moles. We need to find the mass now. So using the formula that moles is equal to mass divided by the molar mass, which for hydrogen is 2. So mass would come out to be equal to moles multiplied by, which is 1.79, multiplied by the MR of hydrogen, which is 2. Because H is 1, so each 2 molecule has an MR of 2. And the answer comes out to be 3.58 grams. So this is your answer. This is the mass of hydrogen that would be needed. That would be needed to produce a current of 0.01 amperes for 400 days. The last part of the question states, wants you to state one advantage and one disadvantage of using fuel cells to power road vehicles compared to hydrocarbon fuels such as petrol. So one advantage of using fuel cell is that they are renewable, and which means because they are running on hydrogen and oxygen, these are easily available. Whereas hydrocarbon fuels are non-renewable, they get used up and they eventually they'll be going to run out of hydrocarbon fuels. And the other advantage is that they are pollution free, because water is the only byproduct that is produced. One disadvantage of using fuel cells is over hydrocarbon fuels is that they are expensive. Plus there's another disadvantage, that since they're using hydrogen and oxygen, so it's going to be very difficult to store gases. So you need very high pressure containers that can sustain high pressures, and that would also make them susceptible to explosions as well. So these are the two disadvantages, these are the two advantages of using a fuel cell.